Hi, everyone. Little bonus video, I guess, because I had a couple people who are particularly interested in this one problem. I've forgotten which exact problem number it was, but the idea was create a radical equation with three solutions, one true, two extraneous, and just see if you had any ideas about that. And my first response to them is the article that you read for homework after Tuesday's class, do Thursday's class on September 17th, talks about exactly this problem. So that might be insightful, useful. They discuss three methods. I'm going to present one method to you that, maybe it'll just be or like resolve your curiosities about the issue. So yeah, I'm going to add a couple slides to this week's Jamboard. How do you create a radical equation with one true and two extraneous solutions? That looks like I did not spell extraneous very well, but I can't stand looking at it's wrong. Hold on, extraneous. I think that's it. I do want you to know I'm not going to expect that you be able to do this type of thing for your quiz or for future tests. I think this was just meant to be an extra challenge for a question. I'm going to follow their second method. So in that article, I'm going to follow the second method, and more or less what it said. So I'll go ahead and write the task here. Create radical equation with x equals -5 true and x equals -1, x equals 4 as extraneous solutions. So we see that there's three solutions. We know we're going to need a cubic in here of some form. That's the only way we can create this situation. So first step, as suggested in the book, well, let's go ahead and create a cubic function with those three solutions. I'm not going to be pedantic and write out what I just said, but I'll say it one more time. First step, let's create a cubic with those three solutions. So that would be x plus 5, x plus 1, x minus 4 equals 0. Multiplying that out, y'all, I'm going to have to ask you to do this on your own. X cubed plus 2x squared minus 19x minus 20 equals 0. Okay, so I have a cubic with those three solutions. Second step. Do you remember the idea of adjusting by that perfect square that we had practiced in the previous video? I suggested, so what is the perfect square that will make this work? And here I'm going to make a big jump. The article will discuss this. I hope it's actually something you might explore, but we need a perfect square such that ax plus b is less than 0 for all of our extraneous roots. Really think about what that means. That means the linear function, we're going to have a slanted function. We want it to appear in the negative y, in the bottom half of the coordinate system, because we know the square root function lives entirely above, right? So if my linear is below 0 for the places where we get extraneous roots, and in this case, x equals -1 and x equals 4, and we want ax plus b to be above 0 for our true solutions. X equals -5. So close your eyes for a moment. I can just play around. I might play around with a function that has those sorts of qualities, right? Let me go ahead and turn that on. Now I want it to be above 0 at x equals -5, and then below 0 over here and over here. So I definitely know I'm going to need a slanting down line. Let's see. I need it to be above 0 at -5 and below 0 at -1 and 4. Well, if I get it below 0 at -1, it'll be there. So I just need to move this down. So instead of +3, maybe go to -3. That does it. For the purpose of the work I did, I went ahead and selected -x -4. So going back to my Jamboard, I'm going to say pick -x -4. Note, -x -4 squared is x squared plus 8x plus 16. All right, let's go on and continue. So step C says, let's add that perfect square to both sides of the equation, of the previous equation. So I had x cubed. So when I say previous equation, I mean that cubic that had the 3 solutions we wanted, right? Plus 2x squared minus 19x minus 20 equals 0. I'm going to add x squared plus 8x plus 16 to both sides. On this side, I'm going to write it this way. These are equivalent, but I'm writing it that way for convenience. Add this, I have x cubed plus 3x squared minus 11x minus 4 equals -x minus 4 squared. Remember, the purpose of creating a perfect square is so I could take a square root and things would look pretty. So I'm going to take a square root of both sides and I'm going to just flip things. So I have -x minus 4 equals the square root of x cubed plus 3x squared minus 11x minus 4. That's it. That should be it. Oops, you know what? Darn it. I recorded without moving to that page. Darn, I'm not going to redo it. Very sorry. Darn, that's terrible. Well, take a look. I'll just talk through it one more time. What I said I would do is have take the original cubic with the 3 solutions as I knew and add the that perfect square to both sides. Note this perfect is equal to that. So I just wrote it in the 2 different formats, but this is an identity. These 2 things are always equal to each other. And when I add it to both sides of this equation, this has the same solutions as this, right? But what I've done, so I have that, and I wanted this perfect square so I could do the square root on both sides and create this radical equation. That was the main goal, right? So square root of -x minus 4 squared is -x minus 4, and then the square root. And so this has the exact same solutions as this original one, except I've introduced some extraneous. So let's go look at Desmos and confirm that's what happened. So again, -x minus 4 and this square root. Let's turn it on. Ah, beautiful. Look what we got. Here's our true solution. And confirm -1. And it looks like it's just off the screen. +4 are my extraneous solutions. Bingo. Done. I hope that was a useful little discussion. That's exactly what it says in method 2 in the article I asked you to read on as homework on September 14th. Okay, hope that was useful. Thanks. Bye.